As we take a look at example 2, what we need to look for is a variable that's going to be the easiest to eliminate 2 times. And so if you look, the z is really easy to eliminate 1 time because I can just add the top equation and the middle equation, and that will eliminate it 1 time. It's going to be somewhat more challenging to do it the second time because I'm going to have to multiply one of my equations in order to eliminate z again. But that's the best option on this particular problem. If you look at the y's, you would have to end up multiplying the equations twice in order to eliminate the y's 2 times. The same thing is true for the x's. It would not be very fast or clever to eliminate the x's in this particular problem. But because the z's are set up nicely to eliminate easily once, it's not that difficult to get them to eliminate again. And so just like we've been doing, I'm going to color code my 3 equations here. I'm going to have the top one be green, the middle one be blue, and the bottom one be red. And what we want to do in order to eliminate z for the first time is we want to take this equation, the green equation, and add it to the blue equation. And so we're going to take green and we're going to add it to the blue, and that's going to eliminate the z 1 time. And so if we just do this by inspection, what we're going to see is that we will have x plus 3x, and so x plus 3x is going to give us a total of 4x. The y's are going to add together in order to give me positive 6y, and then the z's are going to cancel out just like we wanted to. This is a negative z, this is a positive z. When I add those 2 equations together, those z's cancel. And on the right-hand side, we're going to add 20 and 8 in order to get 28. Now, for the second time to eliminate z, we're going to have to multiply one of our equations by a constant in order to get this to work. And so if we take a look, it's probably easiest to take this negative z and multiply it by 2 in order to cancel out with this z. And so that would be the green and the red equation that I'm going to work with. What I'm going to have to do is I'm going to have to multiply 2 by my green equation. And so my green equation is x plus 4y minus z is equal to 20. And then, because that's going to make the coefficient in front of z a negative 2, once that 2 gets distributed to that term, when I add it to my red equation, that's going to eliminate the z again. And so we're going to add this, in this particular case, to our red equation. And our red equation says 2x minus 3y plus 2z is equal to negative 16. Okay, so when we do the arithmetic here, we're going to end up having 2 times x, which is 2x, plus 2x is going to add together in order to give me 4x. When I look at the y's, I'm going to have 2 times 4y, which is 8y, plus negative 3y. 8 plus negative 3 is positive 5y. When I look at the z's, remember we want those to cancel, so let's just double check that they do. 2 times negative z is negative 2z plus a 2z does in fact cancel the way that we want it to. And then on the right-hand side, we're going to have 2 times 20, which is 40, plus a negative 16, which is going to add up in order to give me positive 24. And so now what you notice is that I have 2 equations with 2 variables. Here I have 4x plus 6y is equal to 28, and here I have 4x plus 5y is equal to 24. And so what I'm going to do is I'm going to write those equations just on top of one another so that we can try to eliminate another variable. And so I've got 4x plus 6y is equal to 28, and I've got 4x plus 5y is equal to 24. And so now what I'm doing is trying to find another variable with this little tiny system with 2 equations to eliminate. And if you take a look, the easiest variable to eliminate here is going to be your x's. All you're going to have to do is multiply one of the equations by a -1, and that will cause the x's to cancel out whenever you combine those equations together. And so what we're going to do is I'm going to take this second equation and multiply it by -1 and then add these things together. And so 4x plus 4x times -1, well, 4x times -1 is -4x, and then when I add that to positive 4x, those two terms are going to cancel. Then I'm going to have 6y minus 5y, and 6y minus 5y is going to give me 1y, is equal to 28 plus 24 times -1. 24 times -1 is -24, plus a 28 is going to give me y is equal to positive 4. Okay, now that we have y is equal to positive 4, what you can do is you can come back to either one of these two equations right here, substitute in 4 for y, and then solve for x. And so if we do that in the first equation over here, we're going to have 4x plus 6 times y, which is 4, is equal to 28. And so that's going to give us 4x plus 24 is equal to 28. Go ahead and subtract over the 24 so that you get 4x is equal to 4. And when you divide by 4 on both sides, you're going to get that x is equal to 1. Now that we have the values of x and y, we can go back into one of the three original equations in order to solve for z. And so if we just pick the first one, we're going to have x, which is 1, plus 4 times y, which is 4, minus z is equal to 20. And so this is going to give me right here a total of 17 minus z is equal to 20. Go ahead and subtract your 17 to the other side. Don't forget to bring down your negative. And so negative z is going to equal to positive 3, so that positive z is equal to negative 3. And so for this system of equations, we have the ordered triple solution 1, 4, -3. Remember that we write these in x, y, and z order.